Okay. Speaking for a friend. Okay. All right. So my shapes that I put, I'll go through this really quick. I put a triangle and a dodecahedron. Okay.
Those are fun to make.
They are. Okay. And then I'll get into real world uses for them later. But those are the shapes that I was talking about. Okay?
For two-dimensional, I put rhombi as my favorite.
I put a diamond.
It's a plural form of rhombuses.
So you want more than one rhombus.
Yes.
Okay. Answer problems 3 and 4 in your worksheet, and then we'll come back together. I'll give you 2 minutes for that. I think that sounds good. Actually, I'll give you 2 minutes. Okay, so I'm going to go through my shapes, and I'm going to talk about real-world uses for them and different properties of them. Okay, this is a little bit more in detail than what I was expecting you to give. So one thing, we did talk about this last year, right triangles. Yeah. You remember which you weren't here for that, but the right triangles, what did we say that people use them for in real life a lot? Okay, construction.
Yeah.
All right, they want to make walls with them. Okay, so like you've got a right angle in the corner of the room, and to double check and make sure that angle is 90 degrees. You know, they're going to make a 3, 4, 5 triangle. And if that triangle is not a 3, 4, 5 triangle, then their angle is not a 90-degree angle, and they're going to have to remake it.
Or else the wall collapse.
Yeah, or they just use the 3, 4, 5 triangle to make the angle to begin with.
Yeah.
The wall does not collapse. Well, it could potentially.
I remember we had to watch an entire video on that because we were confused on walls.
Yeah.
What is that?
Okay, so that's an in-center. That's a little bit over your head. That's geometry. Remember, you get 2 geometry class. Okay, so basically, that angle A right there, let's say angle A was 60. Now it's a 30. All right, so they cut that angle in half and they stuck a line out from it. Angle B at the top. Let's say that was a 40. Now they cut that in half. You've got 2 20-degree angles. Okay, they stuck a line going through there. And you get to point A in the middle. And the cool thing that we find out about point A is it's always going to be on the inside of the triangle. And then the other thing is, if we were to make a circle that extends so that it touches one side once and only once, okay, it forms a right angle right here. All right, and then it likewise forms a right angle with those other 2 sides as well. So this point is equal distance to that line at its shortest point, that line, and that line. Okay?
Everything you said sounded like gibberish to me.
It's equal distance. We found a point that was equal distance to all 3 of those sides. Okay? That could be useful in real life. You know, maybe you want to stick a park in between 3 roads.
Why?
Right? You might. I don't know, Andrew.
I'm not building a park. Why would I need to know?
I'm not building a park either. I'm just saying. Okay? There's 4 more qualities. Okay? One of them, they've got the in-center there. The one that's really cool to me is that centroid, though. Okay? So basically, this side and that side are congruent to each other. Okay? So these 2 angles, a lot of times they're not going to be congruent. Sometimes they are. All right? But now, it's going to the midpoint of this other line. So from the opposite angle to the midpoint, opposite angle, midpoint. Okay? And you get the centroid. And if you were to take a pencil and balance it on that little point there that we found, the centroid, it would, balance perfectly. Okay? With a pencil, it's pretty hard to do.
Prove it.
Usually whenever I've got a triangle.
Make a triangle right now.
Here's a pencil.
I've got one with a...
Do you have a triangle prepared?
No, I should have one with a centroid on it somewhere.
Did you prepare this just in case someone like me would say prove it?
I had it. It's bad.
There's no way. No way.
Straw. Okay?
That's funny.
Down perfectly.
Hold on.
Are your hands too shaky?
Probably.
I can see it shaking.
Yeah.
I cannot.
I just have Gucci eyesight. Oh my goodness.
Told you.
Yeah, it's shaky.
Oh, I'm sorry, but that's a centroid. Okay.
I can't believe you seriously did that because I said prove it.
Well, I already had the point labeled and I had a triangle. So, centroid is pretty cool.
I can't even think of an argument to that. You just proved me wrong.
Why do it lost?
Yeah,
It's for today's project, but anyways, that's centroid, and they also use that for other things. We find out that basically any three-dimensional object has got a certain balancing point to it.
Yeah,
So
those
like,
actual triangles.
so like for a rectangle, a rectangle would be dead center on this point. Now this one's going to be a little bit different because I've got my camera, I've got different things, it's weighing in different directions, but if it were equal, it would do that. Those pyramids you were talking about, they actually used, I think it was centroids that they used.
Pyramids, I also put mine.
You put pyramids on yours?
I put
Okay.
the pyramids of Egypt and tip of an arrow.
Tip of an arrow?
I just put each of.
Back to this really quick. Basically, they use centroids, or one of those four qualities, I can't remember which one, to find out, you've got those pyramids coming up. They've got a lot of pressure that's getting ready to, weigh them down. They could collapse, all right? And so they use the centroid to figure out, okay, this is the point that we need to put a pillar at right underneath of it to be able to support that
I
triangle.
hate to say this, but you're right. That actually is true.
Yep.
How dare you be right?
Why do you know this?
No
He
comment.
studies everything.
No comment.
Okay, inscribed angle theorem. How many degrees are in a right angle?
90.
90.
Not
Okay.
even.
92 min. Okay, how many degrees are in a straight angle? We're in a straight line.
360.
Nope.
180.
180. Okay, so if I were to measure, from A all the way around 2C and D is my center, okay, it's 180 degrees. What's 90 times 2?
180. 180.
180, okay. So that's the inscribed angle theorem. This line right here goes right through the center. That's our diameter. Once again, not stuff that I expect you guys to know. I just think it's pretty cool, so I want to show you.
If you think this is cool, I
He's a
am
math
scared.
He's a math teacher. He has to think this is cool.
Thank you for just roasting me.
No problem.
Well, he's also Italian.
Yeah, there is that.
Back to this. Okay, we also find out that if I were to take a line through C, through O, that would be a diameter in this case as well. Okay, and so what you find out is this angle right here, angle O, is double of angle C. Okay, so just a cool little triangle proof for you. And then we use triangles and bridges a lot too. And we can even tell there's a tad bit of a curve, but they're using a lot of triangles.
Why would you use the inscribed angle theorem?
If you wanted to double your angle that you had,
Why?
once again, the Greeks, they had to. They had no other instruments. What were your guys' answers for two-dimensional? What were your shapes that you thought were special?
Yeah, the rhombus.
The rhombus. Okay, what could you use it for in everyday life?
You could use it for like tiles if you wanted.
Tiles. Okay, tiles in school or something.
I picked the diamond.
A diamond.
In my old apartment, we had a window that was a diamond.
Okay.
Yeah, but when
Cool.
my grandpa's door that's a diamond.
It's a diamond?
Triangle because you can cut these like using triangles and out these.
Okay. What's the technical word for a diamond? All right. Instead of saying a diamond, what should the mathematicians say?
I have no idea.
Rhombus.
It's a rock.
Or rhombi if you're being plural.
Yep. All right. Did anybody else have any answers?
For my 2D, I did a star, and the stuff that I listed: stars in the sky, star stickers for little kids, wearing star clothes, star tracing for art class, triangles because the stars are only 5 triangles with the pentagon in the middle.
Technically,
I was
stars
literally
in the
just
sky
drawing that
are
something. I was like,
shaped
wait, if I draw something
Stars would be awesome, and then there is a pentagon in the middle. If you think about it, that's pretty cool.
That is actually pretty
And then I just went to, with pentagon and
Dodecahedron.
It's 3 triangles.
Yep, so dodecahedron, not a whole lot of uses for them, in all honesty. Rubik's Cubes, if you've seen the one that I got, art, and then like that dodecahedron on the right. So what I looked up is that thing is Greek, and basically they don't know what they used it for, but like I saw a whole bunch of different things. One was knitting, and then another one was coin checking. So basically, you come up with a quarter, you stick it through the slot that's supposed to be the quarter slot. If it goes through, then check it well. And if it goes through a nickel slot too, then it can't be a quarter. It could be a nickel, but so you stick it through the quarter slot and it works. You stick it through a nickel slot, it works. You stick it through a penny slot, it doesn't work. Well, then we're stuck at the nickel. That's gotta be what it is.
You better not be trying to sneak a nickel and it says a quarter.
Thank you, Andrew. You're welcome. All right, what did you guys put for 3D?
I put a cube.
Okay, what do we use that for?
Storage inside the cube. Using the cube in math class. Boxes, because some boxes are cube-like. Some rooms are built like a cube. And cube cups.
Cube cups?
Yeah. Cups that are like the cube but have a hole in the top and you use them as coffee cups. That's what I call them. I don't know what they're
Building
called.
blocks.
Cool.
Yeah, building blocks.
I could see that now.
Actually,
Got that in
that
my head.
A house.
Autumn, do you have anything? Triangles? So like pyramids?
Yeah.
Yep.
Blocks.
Okay. What did you think of anything that you could use them for in real life?
Construction.
Construction. Okay, so maybe constructing a pyramid, like the Bass Pro.
The Bass Pro Shop Pyramid.
That one. Okay. Alright, so they all use spheres to their advantage within the item in nature or man-made product. Okay. So what about the orange? Why is an orange circular and not why isn't it shaped like a pyramid? Or
Just how it's grown.
okay, kind of how it's grown. It's got to have some advantage.
It's like your milk jug.
Is it?
That is not.
It's able to spread nutrition throughout the orange faster.
Okay, cool. That would be awesome. So it equally
Spreads
distributes.
out. Yeah, it doesn't have to worry about any edges or anything. Just
You actually knew that.
don't ask.
That's okay. Cool. I hadn't even said that today. Okay, have you learned anything about microevolution in science class or anything like that?
No, mine
Okay.
goes.
One, you don't have to know. Well, you don't have to, disbelieve in religion just because you believe in evolution. You don't have to believe in religion just because you believe in evolution. Okay, so I'm not stepping on any toes by saying that. Just FYI. So basically, here's the thought process. Let's say this orange, instead of being rounded, it's like a square. Okay, it's kind of lumpy. All right, it falls off the tree, hits the ground. Where is that cube of an orange going to go? Okay, you're saying you think it's going to
Either break or just not land anywhere because it's just going.
It's just going to stay there. Yeah. So if it doesn't break, which it's more likely to break if it is cube shaped because it's got some pointy edges.
Weaker points.
Yeah. Okay, so there's one disadvantage. But if it's rounded, it hits the ground.
It can roll.
It could roll and maybe go further away from the tree. Do you think a tree would like it if the seeds just stayed all right there? Does the tree kind of?
It wants it to spread out.
Yeah, that way it's got a better chance of reproducing, having more of those orange trees. I think oranges grow on trees.
Yes.
Okay. All right. So I'm getting fact
The orange tree got the name orange before the orange had colored it. There you
I did not know that.
go. Well, the tree was the first thing
That
colored.
was always such a controversial question. Which came first? The
Orange?
color.
Well, the tree actually.
Autumn, now that we know all that about the orange, why do you think it might be an advantage for us to have Christmas ornaments shaped like a sphere?
If it falls, it's less likely.
Are
to
you
shatter.
Autumn?
Howdy, Alan.
Yeah, I did get poker once.
Okay.
Hey, Autumn.
What did Andrew say that orange could do if it was cube shaped and it hit the ground? Okay, it might blow up and just okay. All right. But if it's the Christmas ornament, it's round shaped. Maybe now whenever it hits the ground, what is it less likely to do? Break, okay? Because that little vibration or that little hit or whatever, it kind of shakes throughout the whole thing instead of a whole bunch of pressure on one point. Have you guys ever seen like those slow motion videos where a baseball is getting hit with a bat and it kind of smushes and then it it vibrates a little bit and it goes back.
It's
Okay.
cool.
So obviously that's not going to be able to bend as much, but it'll But it'll, I mean, if it got hit with a bat, yes. But anyways, that's my point. Is it's gonna be able to shake a little bit more as opposed to if it were.
It still would be pretty fragile, but it'd be less likely to explode.
Yeah. What about a balloon? Whenever you blow a balloon up, you start inflating it. What were you gonna say?
Oh, I was gonna give my answer of what I think it is.
For the balloon?
Yeah.
Okay.
I think it's because air is sort of like a fluid. Whenever you put a fluid into rubber, it bends that way. So air would bend that way too.
Okay. So that air is trying to, trying to get out. All right, but it's tied, so it can't. So why doesn't that balloon just like lump to one side? Why is it that most of the balloons that we have kind of
points?
Yeah, because it's putting too much pressure on one point still, and so that one point would just go pop. But if it kind of stretches out evenly on that balloon, we can fill it up with a little bit more air.
And it won't ruin Jimmy's birthday party.
Sorry, Jimmy.
Okay.
How do milk jugs use spheres? How do they take advantage of them?
The lid.
Okay, the lid is more like a cylinder. The dent, what's the deal with the dent?
It's a half circle.
Okay, it is a half circle.
It tells you if it's expired or not.
Okay, it doesn't necessarily tell you if it's expired, but a lot of times whenever...
It'll pop.
Yeah.
Let me just put them in for you.
Yes, please. They're all done. That doesn't mean that it's expired. That just means that, a lot of times whenever it does expire,
It can do that.
Yeah, it starts to expand and everything like that.
It at least gives you a hint that it might be expired.
Yeah, and so instead of the whole thing just going boom, it would pop out. It'd be better to, open your refrigerator up and that thing is popped on your milk instead of opening your refrigerator up and your milk jug is exploded everywhere. Ariana had that happen.
I think it'd be a really bad idea to make a milk jug shaped like a sphere because if you open the shelf, it's just going to roll out.
Okay, so that's a little bit of spheres. I think I want you to answer 6, 7, and 8.
Okay.
No, I'm turning on lights. Okay, so a lot of times whenever you are, blowing up a balloon, whenever you go to air that balloon up, or not balloon,
Is that what the blue fluid is for?
Yeah. Okay, you go to blow a bubble into the little bubble wand. What shape is the little?
That's
The hole.
Okay, and it's going to be spherical. Okay, so not a shock. I dipped this. If I can get a bubble, and we're going to get one. Okay, kudos to me. All right, now if I use a triangular shaped one.
Weak.
All right, what do you mean it's not going to work very well?
Well, there's weak points. Once again.
Isn't that just going to? I'm going to blow a pyramid, and a pyramid's going to come out.
See how that goes for you.
I'm not going to say names, mostly because we're recording, but one of my students this morning definitely thought it was going to be a pyramid.
Ha!
One of the 8th, 9th graders.
Yep, no names mentioned.
Called.
No names mentioned, though. Okay.
Weak points.
Why is it that it's always going to come out to a sphere, though, or a ball, and not like a pyramid? Like it is a triangle shape. Why does it not? Andrew?
The shape of your breath is a sphere.
What?
I don't know.
Okay.
I had an answer for most of them. I don't have an answer for bubble size.
Okay. It's honestly a lot closer to the same exact answer than what you think. Okay? Because as I'm blowing that in, it's trying to expand out and then like kind of come back together and make a new shape. But it's trying to enclose, and it's trying to enclose, all that air, because it's got air inside of it, and it's trying to do it with the least amount of surface area, because the more surface area it has, the more that the soap and the water and everything has to expand out.
You
And
have a
then it'll pop.
hexagon bubble thing? Or hexagons?
What about it?
Hexagons. What about hexagon bubbles?
It would still be a sphere.
Exactly.
Still, you haven't tried the hexagons.
All right. So we've all got that question answered.
Yeah.
Answers 6, 7, and 8. Okay. So what do you guys think is going to happen? I'm literally just dipping it in, and then I'm pulling it out.
Just be glossy.
Okay.
I thought you were gonna blow on it.
Yeah, I kind of should.
I think it's just gonna pop.
It's not going to pop, actually.
Oh.
I thought it was gonna come out circular.
If I can get it to do what I need it to do. So let's watch.
I thought you were trying to make like a really bad boat or something.
Okay. You can kind of see it here. It didn't quite do it as much as I wanted it to. Huh?
Plastic.
Okay, so some of those sides are connected, some are not.
I think it's trying to focus too hard on one side and then ends up going to the other.
If I can get it. Alright, now we've got it perfectly. Okay, you guys see how it kind of comes to the middle there?
Oh yeah.
Alright, what shape is that little bubble at in the middle?
It's a sphere, I think.
Okay. Kind of like a triangle, a pyramid. Okay. Does it look sharp? Does it look like it's a perfectly flat bubble?
No.
No. Okay. So here's the reason why it's coming to the middle, and it just popped on me. Okay. The reason why it's coming to the middle is because if it comes to the middle, it'll kind of share a side. So like look in my little dish soap that I got. Do you see very many bubbles by themselves?
No.
Why?
Because they're clumped
they
together.
Okay, why do you think they're clumping together though?
The soap.
Okay, good answer, Autumn. Alright, but so because of that soap, they come together and basically what happens is they're sharing a side then, right? And so it's like there's not as much soap that it has to, I guess, put out to cover that area. And so it's like a thicker coating around that one bubble. And so whenever I had my triangle, they were all going to the middle because now this side is sharing a little bit of this one side, that one side.
They
that
were
one
sort of
side.
like connecting them.
Yeah, they were sharing sides to save area.
Well, that sounds like climactic.
Well, I thought it was cool.
It is cool.
And then the one in the middle though, you won't always have that bubble. Sometimes you'll have the bubble, sometimes you won't. But basically, if I were to inflate that more and more, it would still stay that pyramid because it's still trying to, share a side with the rest of it. Answer 9 and 10 on your worksheet.
You just answered number 9 for us. Why do you think it?
Yeah, I did answer 9.
Thanks.
Dang it.
I don't even know what it is.
And I answered 10.
Did you answer it for me?
Did you answer number 11, hopefully?
Should have. If not, I'm going to get an image up there for number 11.
A single bubble in the air is always a sphere.
Are you watching videos on how to do this?
Now I'm going to the video for you.
Wow. So perfecting that.
Okay. So if you want to take a look up at the screen, that'll help you with 11 and 12. And so basically, if she didn't have that bubble in the middle right there, they'd all just kind of come to a point. If it's a true cube. So mine was a rectangle, and I couldn't get it to do it. But earlier today, like I had dipped it in there, and then whenever I pulled it back out, all the sides were connected, and so it was like on the ends. On the end here, it was like it was just kind of coming and meeting at one point, but then you turned it and you looked this way, and it was like it was coming in and it was meeting in a rectangle.
It's like a really bad intersection.
A really bad intersection. Yeah. So I thought that was kind of cool. Something I tried showing you guys, but I couldn't get the second shape to do it. So it is tragic.
It is but tragic.